the systems that we use and the power requirements that they have are getting bigger all the time. Every system we're putting on a ship now or in an aircraft is in some ways sort of a power hog. The Army did a study that for every 24 convoys, we lose a soldier or a Marine killed or wounded guarding that convoy. That's a high price to pay for fuel.
There are so many applications. Literally, fuel cells span from less than a watt to megawatt in potential applications.
It's going to reduce CO2, it's going to make our country more secure, it's going to conserve resources, and it's going to create high technology jobs.
A more widespread implementation of fuel cells is really limited by their immediate cost. The cost of a fuel cell is high compared to their competition.
They're still being mostly made with manual labor, and it's because the volume requirements have not come forward.
So now you got to get more serious into upping your manufacturing readiness level to be able to really drive to reliability, ruggedness, and reduce costs.
It's a great technology. How do you get it out of the lab and in the hands of the people?
When was the last time that an American technologist said, well, we got a problem, it's too big to solve? We never have.
Manufacturing, affordability, those are the two key words of this effort.
We need to understand where we are, or where the current state of art is, so that we can actually understand what the gaps are.
And then what's a better approach? How can we close that gap? In other words, if we're doing something by process A, which is costly and ineffective, is there another process B, that might reduce that cost?
What is not requiring $100 million in tooling that would give you a big priced reduction?
We turn a problem statement, the gap, into a solution set, which is a set of projects that can inform government program managers, industry themselves, as to how we can get from point A to point B.